What are the pharmaceutical applications of this thermodynamics concept? So it is used in prediction of drug stability. It is used in solubility and dissolution of drugs. Then it is also helpful in predicting the shelf life determination. Then phase transitions like solid to liquid and liquid to gas. Then it is used in colorimetric studies of the drug interactions. So here are some. Hi everyone, welcome back to my channel Pharma Talk with Imran. In today's video we are going to discuss regarding thermodynamics in physical pharmacy. So here we are going to focus on different topics like system. In that we are going to study open system, closed system and isolated system. Then the important terminology like internal energy, enthalpy, entropy, then Gibbs free energy and laws of thermodynamics. In that we are going to see Zeroth law, first law, then second law. Then we are going to deal with another topic, that is Gibbs free energy. Then what are the pharmaceutical applications of this thermodynamics? So it is used in drug stability, solubility, shelf life, then phase transitions, to study the phase transitions. Then we are going to focus on examples and numericals. So let us start the video. First we will see system. System means what? It is a part of universe which is under study. That is called as system. It is a simple definition. In that system there is three type of system, that is one is open system, closed system, then isolated system. What is open system? Here there is exchange of both, that is mass as well as energy. Example, here we can see the beaker. Here there is an exchange of both, that is mass as well as energy. Another system is there, that is closed system. So in this system there is exchange of energy only but not mass. For example, here we can see the electrical bulb. Then isolated system. So here there is no exchange of mass as well as energy. Example, thermos flask. Then thermodynamics in physical pharmacy. So the study of energy change that occur in physical or in chemical process. Laws of thermodynamics. The first one is Zeroth law. What Zeroth law says or states that if any two systems which are in thermal equilibrium with the third system, then they are in thermal equilibrium with each other. For example, the system A and the system B are in thermal equilibrium with system C. Then it is clear that if the system A is in thermal equilibrium with system C and system B is thermal equilibrium with system C, then the system A as well as system B both are in thermal equilibrium. That is what the Zeroth law says. That is, if A and B both are in thermal equilibrium with C, then definitely the system A is in thermal equilibrium with system B. That is, A is equal to B and B is equal to C, then A is equal to C. Then all three systems are in thermal equilibrium. We will see the laws of thermodynamics. The first law of thermodynamics. So it states that the energy can neither be created but nor be destroyed, but it can be only converted from one form to another form. That is, energy we cannot create and we cannot destroy, but we can only transform from one form to another form. So that is what the first law says. Here we can represent it as in the form of equation, that is delta U is equal to Q minus W. Here delta U is equal to change in internal energy, Q is equal to heat added to the system, then W is equal to work done by the system. So what is the pharmaceutical relevance here? So here it is it is used in colorimetry, and it is used in calculation of heat of solution. Then what is second law of thermodynamics? So here the entropy of an isolated system always increases. That is, natural processes are always irreversible and energy transformations are not 100% efficient. First, to understand this law, we should know what is entropy. Entropy means what? So entropy means, here it is a simple concept. Means entropy tells us how much things are in arranged form and how much things are in disarranged form. Just imagine, so we have a rack, we have the racks, in that the books are placed in an arranged manner. Now the entropy is in decreased condition. Similarly, if I randomly throw these books in the same system without any proper arrangement, then the entropy is very high. That is, the entropy tells us in any system how much the things are in arranged form and how much the things are in disarranged form. Similarly, when we take a example for a gaseous substance, just imagine we are going to have a perfume. The smell of the perfume is limited. Means we can only smell the perfume smell. But when we spray this perfume, the gas, or you can say the spray, is randomly arranged in the room. Then the entropy is more. And if it is in the arranged form, the entropy is less. So in short, we can say entropy tells us how much things are in arranged form and how much things are in disarranged form. If it is in the proper arrangement, then entropy decreases. If it is in the random arrangement, means the entropy is increased. Now, second law of thermodynamics says the entropy of an isolated system always increases. That is, if a system which is isolated, which is not bound, so here the entropy is always increases. Then the natural processes are always irreversible. Energy transformations are not 100% efficient. So here it is in a proper order, that is low entropy. Here the molecules are arranged randomly, then we can see the high entropy. So the delta S is equal to S final minus S initial. Then delta is more than 0. Delta S is more than 0. The Gibbs free energy. Gibbs free energy means what? So it is represented by a equation G is equal to H minus Ts. So here G means Gibbs free energy, H is equal to enthalpy. So enthalpy means what? Enthalpy tells us in a system how much of energy is, that is especially heat energy is absorbed, and how much of heat energy is removed. So in the easy understanding way, it tells us how much heat is inside or exchanged in a process. So for example, in any process from a system, how much of heat energy is removed in that system and how much of heat energy is absorbed in that process, in that system. So that is what the enthalpy means. Then T is equal to absolute temperature, which is used by a unit called as K, Kelvin. So here absolute temperature means what? Absolute temperature means it is the exact measurement of temperature, exact measurement, that is from 0 to present temperature, from 0 to present temperature, that is absolute temperature. Then entropy, it is already discussed. Then the spontaneous process, spontaneity of a process is like this one. If the delta G is more than 0, then the delta G is negative, then it is the nature of process is spontaneous. If the delta G is less than 0, then the impact is positive, that is delta G is positive, then it is a non-spontaneous process. Then delta G is equal to 0, then the system or the nature of process is in the equilibrium condition. There are some examples. Melting of ice, that is leads to water, delta H is positive. Boiling of water, that is water to steam, delta H is equal to positive. Condensation, that is steam to water, delta H is negative. Sublimation, that is solid to directly vapor, skipping the liquid state, that is delta H is equal to positive. So positive means endothermic, negative means exothermic. So the thermodynamics help us to understand the energy changes in the drug and the dosage forms. So here are some important equations. Delta U is equal to Q minus W, delta H is equal to delta U plus P into delta V, then G is equal to H minus Ts, delta G is equal to delta H minus T delta S. So here is the question, that is the change in Gibbs free energy for a reaction is negative. What does this indicate? Option A non-spontaneous, option B spontaneous, option C at equilibrium, then option D no reaction. If you know the answer, please answer it in comment section.